Yeah, so this is Obol V2. Today we are on our roadmap to V1. At the moment, we're about 60-70% to V1, but we've been working on a parallel work stream, which is Obol V2. And Obol V2 further protocolizes DBT by turning it into a specification. So we've actually partnered with Nethermind for them to be the second core development team for the Obol network. And they will be leading and partnering with the Obol Labs, current core development team for the Obol network, to work on the research and specification of the Obol V2 protocol. And we are pushing towards a spec-driven environment where we hope to incentivize a variety of different implementations, right, for different people's use cases. And the reason that we're also doing that is to kind of the prior story that I told, which is you need to be as close to the base layer from a variety of different perspectives as possible. One of them is roadmap. You have to keep your roadmap on. You can't get in front of the mothership's roadmap. You got to kind of hang out in this Goldilocks time period. And yeah, those are the most important things that you have to follow and kind of stay on top of.
Yeah, there's one extra thing I want to add actually about the middleware side, or as you said, like why don't the client teams implement it, directly? This is something we looked at ourselves for quite a while, and it's actually why I touched on BLS signatures being aggregatable being so important. And I'll talk about it kind of by way of talking about Mev Boost and before that even Mev Get. So for those of you that aren't familiar, Mev Boost is now the product like run by Flashbots that allows, people that want to get, inclusion into blocks without getting front run. They kind of talk to validators through the software. But before it was called Mev Boost, it was called Mev Get. And it was just a slight modification to the original Get code base. And they were highly successful in their rollout. More or less all of the Ethereum miners back in the day were running Mev Get to the point that people are concerned it was north of 90% of clients. And the Ethereum Foundation were kind of concerned about this. They were like, okay, if there's anything goes wrong with the software, almost everyone is running it. So when it came time to move towards ETH2 and reinventing it to figure out how it works in this new paradigm with validators, one of the best changes they made was to re-architect MevGet. Instead of it being like a forked client, it's an optional middleware, or more accurately, a sidecar that all of the clients can add. And rather than it being, a feature that only one specific client has and the others don't, it was something that they could all opt into. And this, massively de-risked it and allowed it to be more accessible and didn't, prevent client diversity in any way. And we had kind of a similar issue when we were developing distributed validators as well. The easiest kind of way to make an MVP is to make a standalone validator client that has, arbitrary power to sign. You can build your distributed system to go and run validators this way. Whereas, the kind of problem here is either you have, one client that's super successful and it works, or you have a spec that everyone has to implement. But if you do that, you kind of really slow your roadmap. You kind of have to get everyone to march along at the same time. And you really don't have much optionality. If a new, better version comes along, people can't switch to it very easily. So in the interest of, not, causing harm while trying to do good when it comes to building distributed validators, we realized that we could also build distributed validators as a middleware because of BLS signatures being aggregatable. So right now, all of the existing validator clients, they can add our software into their stack and become a distributed validator more or less with no changes. And this is super beneficial because it does allow, you're not one client or, replacing them all, or if there is, a better spec comes out, or, Obol, goes to zero in the morning, a new one can come along, all the clients can just put in a new middleware, and it's much more modular and it's much more fault tolerant in that regards, that, if something goes wrong, no big deal, people can kind of pivot. And this, design idea is why we kind of went towards the middleware route, and it's, something that's kind of served us well in that regard. But the last leg of it is, just one implementation of the middleware is, sufficient from a safety perspective, but there could still be a liveness risk if, the thing has a bug and it goes offline. That could be a problem. So the kind of further leg of the journey is after you build it once, get some adoption, prove that it works, then it starts to become more sensible to protocolize it, make a spec, have a couple implementations. But even if there is just one, it is still modular, replaceable, and is this, nice thing that if a better one comes along, no big deal, it can be swapped out. So I think that is kind of an important design decision versus why isn't this, a spec that all of the clients implemented, because you can iterate faster, you can try more things, you can have more optionality. And that's kind of the way we've designed the software so far.